Hello everyone. In this video, I will be discussing on memory read and memory write timing diagram, how these have been developed, and how the read and write clock cycles have been designed. So overall, here this will be helping you gain knowledge in the 8085 timing diagram. Let's take kind of an example. I want to move a data or move a content from the memory location into the A register. So this instruction has only one what one output. And then after this one, even though there is only one output, first thing is that this is output fetch cycle you will be having, and the other one would be the memory read cycle. There would be two cycles. In the first clock cycle, you will be going for output fetch, fetching an output. The output is nothing but 7E. This is being fetched from the memory location. At a memory location, which memory location? A000. From there, it will get the output as 7E. Then immediately, as this output will define it as reader data from the memory location pointed at by H and L register pin. So once it sees 7E, microprocessor what it does that it refers to the 8085 H and L register pair. Now this H and L register pair will give the information of data where it is being stored. So microprocessor in the next clock cycle, it will refer to that memory location pointed by HNL, and it will take the data from there and it will be feeding into the A register. This is the overall operation which is being carried on. First, it will know what is the operation to be carried out by using an output fetch. In the second machine cycle, it will read the data from that particular content which is being given by H and register pair, and it will be storing into the A register. So how this is being drawn over here, that is being shown over. So every time output fetch is a 4 clock cycle, then memory read or memory write operation is a 3 clock cycle. Coming to the output fetch, as you know that this is the memory address 00A0. 00A0 would be lower order bit would be 00, which is stored into the A0 to A7, and higher order bits are nothing but A0, which is stored in near higher order address bus. So address bus is being split into two parts, higher order and lower order. And next one is that once you are sending the address, at that particular moment, address latch enable signal is made as high, and next 3 clock pulses, the address latch enable signal is made low, because it should not interfere with the data. So once the first clock only will make address latch enable signal as high, next one immediately will make it as low, and it will be low continuously. Similarly, the read would be lowered at one instant, and it would be after the address latch enable signal has been passed away, this read would be made as low, and this would be lowered for the 2 clock cycles. So during this period, the data would be the most read. What is the data is there that has been read by the mind, and it goes for the processing or execution process. And throughout this process, I mean to say, to the output fetching is an memory read operation. So write would be totally high, or there is no write operation. If you are having a write operation, will be representing with low at the output line of at the write line. And now this one is a memory read operation. So this is not an IO; it is a memory read. We'll refer it as M bar. So this is an output fetch. Now, after the output fetch has been done, then the content stored at the memory location is to be read. So see here, at the first instant when you are sending up the address latch enable, after the output is being fetched, 7 is the output fetch, reading and content from the memory location M into the A, that is to be done it up. So it will read up, it will send up two things. One is an lower order address is been sent onto the L line, and higher address has been H. Whatever the contents of H is the higher order address bus, lower order address bus will be represented by the L register. These two registers will be giving you the address information. So after this one, it is been lowered. So next one, since I go for the lower order address bus, it will be acting as D0 to D7. It would be giving you the content which is stored into the memory location. It would go for the reading the content in the memory location and it will pass over here. So it may be delayed. This one immediately you can't have it at a second clock pulse itself. So second clock pulse will be deferred over there. Then the reason, at least for 2 clock pulses, the read signal is low. It may take some time as these peripherals are slower, so synchronization between them will not be possible. And throughout the read operation, write line is being lowered, write line is being lowered. So, and all this process is a memory read operation. That's the reason it is. Now, next example, if you take it up, as this is an example, move n comma a. Now here it is what the content of a is to be moved, or it would be should be copied into the memory location. So what is this one? Write operation. You are writing something into the memory. So opcode would be the same thing. 77 would be the single opcode. Now here we won't give the memory location address. Nothing would be present in the program. Automatically it will check the it process. Once it sees 77, automatically it will refer to the HL register pair. Whatever the value in the HL register pair, it is been copied into the address bus and it will lead you to that address. And content of A is been copied into the memory data location of here of fetch and L register. So there would be 2 cycles. One is an opcode fetch, 77 opcode fetch one. Since it sees that one, then it would be writing the data into the memory. So for that one, this is the buses which has been represented. Obviously, already you are familiar with the opcode fetch cycle. Next one, this is a memory write cycle. These 2 cycles will combine the read operation or the memory read or write operation of 8085 megahertz. So overall here, by these 2 diagrams, you are able to understand how a microprocessor reads a data from the memory, how a write a data into the memory. So thank you for watching this video, and I hope you had a clear-cut view about what is an opcode fetch execute cycles in your 8085 microprocessor. Thank you everyone.